This next question comes from the Flyback transformer design video. This was a really fun video because we got to go through the entire process of sizing a Flyback transformer, or I guess the coupled inductors that you would use in a Flyback converter. The question asks, Zach, at 6 minutes 44 seconds, I use your calculated 2.57 amps output and then placed it back into the formula to verify or determine the original I secondary peak voltage. I get a value of 7.34 amps. Where did that value come from? Well, the thing that I'll say about that particular value is that it's really not so important except for sizing discrete semiconductors, and in this case, it would be important for sizing any rectifying diodes on the secondary side of that Flyback transformer. The reason that's important is because those secondary side rectification diodes will have a peak pulsed current rating. And you want to make sure that you know what is the peak pulse current you can expect on the secondary side, and then you can size those diodes above that. If you don't do that, of course, you have a risk that those diodes will get hot and burn up, and then you don't have a functioning Flyback converter anymore. Now, normally we just kind of ignore that peak secondary current value because what we're really designing for is an output current, and we're designing that output current based on the maximum input current that the switcher can withstand.